Hello everyone, welcome back to the YouTube channel Devotion of Knowledge. Today we are back again with another YouTube video. As you would be knowing in the previous video, we just understood some of the basic concepts about encryption and its fundamental types. But in this video, we are going to go through some of the very basic terminologies that one should be knowing before solving a complete numerical on SAES. So in this video, we will just have some quick introduction about the basic terminologies regarding SES. So first of all, let us understand what are the size of plain text and key. That two things are must as far as symmetric encryption is concerned. So one is plain text and another one is key. These two things are mandatory as far as symmetric encryption is concerned. So in SAS, plain text is of 16 bits as well as key is of 16 bits. So 16 bits of plain text and 16 bits of key. So both of them are having a similar size of 16 bits. Now, the first terminology that one should be knowing before solving SAS numerical is add round key. So let us say our key as denote key as K and plain text as P. So this plain text is also of 16 bits, 1, 2, 3, 5, 6. Similarly, our key is also of 16 bits. So we perform XOR operation between plain text and key, and whatever result we have obtained, we consider it as the output of our add round key operation that we just did by applying XOR operation. So this was our first thing that one should be knowing. Next one is shifting rows. Now, whatever plain text we are having, we represent it as a matrix of 2 cross 2 like this. It is a 2 cross 2 matrix. 4 bits here 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. For example, 16 bits are there like this. So, first 4 bits will be here, next 4 bits will be here, next 4 here, and next remaining 4 here. So, in shift row operation, we shift the rows, for example, in such a way that this one is row number 0, this one is row number 1. Here we give 0 based indexing. So we shift the row number of times its index means it is given the index. So here 0th row is given 0 index. So we will shift it by 0 times means we won't be shifting that particular row. The next one is 1. So we shift this matrix by 1. So here what we particularly do, we shift this value to here and this value to here. It means we perform as it there are only two entities, so it does not matter whether you perform left shift or right shift, but here we generally swap these two values like twice here. In AES there are multiple matrices available, so in two, for example, we are having like this A, B, and C, and row number is 2. Then we shift it, we left shift this to this particular row by 2. So what will be the output if we left shift it by 2? C, A, B. This will be output because in first shift it will be like B, C, A, and then another shift it will be C, A, and B will be here. So it will be equivalent to C, A, B. Okay, these two terminologies are done. What is the next terminology that one should be knowing is nibble substitution. Next one is nibble substitution. Basically, in SAS, we are given a matrix of size 4 cross 4 like this. Well, this 4 cross 4 matrix is given, and as I told you, we represent our plain text as a matrix of 2 cross 2. Okay, this matrix is referred as state matrix. The matrix in which we represent it as a content of plain text, it is represented or it is termed as state matrix. So, these are the contents of state matrix. For example, this one is 0, 1, 1, 0. Okay. So, in nibble substitution, we substitute this particular value with respect to the matrix given. Okay. 0, 0. Okay. Okay. It is 0, 0, 0, 1, 1, 0, 1, 1. Similarly, 0, 0, 0, 1, 1, 0, 1, 1. Okay. So as it is 0, 1, 1, 0 here, then first two values 0 and 1 are the row that which we are supposed to refer. For example, 0 and 1 is here, and next another 1, 0. It is the column that we are supposed to refer. So it will be somewhat here. 0, 1 is the first, 1, 0 here. So whatever value is present here, for example, A is present here. Then what will be the representation of A in hexadecimal? A is 10, right? And what is the representation of 10? 1, 0, 1, 0. Okay. So instead of this 0, 1, 1, 0, we'll be writing 1, 0, 1, 0 here after applying the operation nibble substitution. So nibble substitution is basically we replace the value or we substitute the value. This means value from the matrix with respect to the value that we are given. First two will represent the row, second two will represent the column. Okay, I think this operation is also done. Last operation that we have to apply while solving AES is mixed column. This operation we are not going into much detail because this much is somewhat confusing, or this can be more understood while solving the numerical only. But let me give you an overview. Here we multiply a matrix with some constant matrix already provided, and we apply some of the matrix division in that, which is done with using some advanced mathematical functions that we will be seeing while solving the numerical. And using that output value, we replace or we modify the particular matrix, state matrix that we are given. So I think all the operations that we need to understand are done. Let me just give you a quick uh, scenario that how these operations are applied. So first of all, we apply add round key operation. First operation that we apply is add round key. It is done with the key1. K1. Then we apply nibble substitution. Nibble substitution. Then we apply shift row. Then we apply mixed column. Then we apply add round key. Again, this is round 1. This much of steps 1, 2, 3, 4, they constitute round 1 of SAES. In the second round, we again apply nibble substitution. Then shift row. Then round key. Add round key at last. These 3 steps comprises of, or they are part of second round. Now you will be wondering, add round key 1, add round key second, add round key third. So total there are 1, 2 and 3 add round keys operations present. And the key that we are given is only 1 at the time of input. So here, with the given key K1, we generate another 16 bit size key which are termed as K2 and K3. So total we are having three keys while performing all SAS numerical. But these two we generate using a key generation function that we'll be seeing while solving the numerical. Neighbor substitution, shift row, and some normal operations, so operations are used while generating this K2 and K3. It is relatively easier. No worries. The only, or we can say only step which takes some considerable amount of time is the step of mixed column. Otherwise, all the rest of the operations are really straightforward and all set. This much is the whole procedure of SAS numerical or SAS encryption process that we will be seeing as soon as we solve the numerical in the next video. And the numerical won't be on this board, it will be on the software that we use while recording another videos because it will require some considerable amount of space for solving the numerical. So here we conclude for this video. This much of terminologies, basic terminologies that were required to understand before solving the numerical of SAS are done. Label substitution, add round key, shift rows, mixed column, key generation, all we just took an overview. And in the next video in which we'll be solving a numerical, we will be going through each and every step present here or that we understood here. So I think we should conclude here. We will meet in the next video. Till then, keep working, keep learning. Thank you very much.